So number 31 says, Tarzan swings on a 30-meter long vine, initially inclined at an angle of 37 degrees with the vertical. What is his speed at the bottom of the swing? A, if he starts from rest. B, if he pushes off with a speed of 4 meters per second. So, here's my diagram. Here's the 30-meter long vine at an angle of 37 degrees to the vertical, and this is our initial height. And then when he swings this way, there's a height final, and this is where we want to find the final velocity when velocity initial equals 0. So we're going to use the conservation of energy equation. The initial kinetic energy plus the initial potential energy equals the final kinetic energy plus the final potential energy. So then this is what it's going to look like, and then we plug everything in. So then to find the height initial, we can draw a slant line here with this vertical line, and we know according to parallel lines that this is also 37 degrees. And then this, if we draw this line, this is 30 meters long, and then this angle is 37. Thus, this angle is 53. And then we can find this height, which is 30 sine 53. And then we calculate that, and it's 23.96 meters. So we can plug that in for height initial here. And then to find height final, which is this, we first find this height, in which we'll do 30 cosine 37, and then to find this little bit here, it's going to be 30 minus 30 cosine 37, and then to find the height final, it's going to be this height initial minus 30 minus 30 cosine 37, which is this right here. And then if we calculate that, we'll get 17.92 meters and plug that in here. And then when we solve for velocity final, we're going to get 10.9 meters per second. So the second part is asking for the velocity final when the initial velocity is 4 meters per second. We're going to use the same conservation of energy equation, and we're going to plug everything in. Here we're going to plug in our height initial, and here's our height final. And then the only thing that's different is that the initial velocity is now 4 meters per second. And we're still solving for velocity final, and if we plug that in, we'll get 11.6 meters per second.